Well, thank you, Laura. It really is an honor to be here. As I was telling Laura at one of the breaks, some very, very impressive speakers this morning and this afternoon, and some really exciting things. I am not a supply chain person, although I do work for a gentleman who used to be the chief procurement officer for Jabil. So I guess I get some genetics in me relative to supply chain. I hope you all got a chance to see Baxter yesterday. I won't spend a lot of time talking about Baxter, but I will talk about the trends that I think are really driving Baxter today. And we have one in our tech center. You know, it's kind of funny. Who would think I'm from Silicon Valley. Who would think you'd leave Silicon Valley to come to the desert of Phoenix to have cooler temperatures and more water? So a little change of venue here. But I am going to talk about how do I do this? Does this put it on? Oh, perfect. Okay, great. So the title of the talk is Redefining Contract Manufacturing Through the Use of Robotics. I've dubbed it the Third Industrial Robot Revolution. I like these characterizations. Anyone who's familiar with Industry 4.0, which is about the fourth generation in Europe, or I love this article written by Supply Chain Management World last fall about the factory of the future, and they've dubbed this the Third Industrial Revolution. So a little bit of plagiarisms, but I think you'll see it ties together. So what does it take to be a robot guy or gal? I hate to say it, but it's genetics. So while all of my classmates were out fantasizing about being astronauts and movie stars and sports heroes, I was relegated to a different life. Can you believe my mom sent me to school like that? It's, so if you want to be a robot person, this is how you got to start your lot in life. So, but I did get my 15 minutes of fame. I spent a session with Steve Croft on 60 Minutes, and back in 2013 about the role of technology and jobs, and very interesting. I mean, they spent 3 hours interviewing to get about a minute of airtime, but I wouldn't give him what he wanted, which was that automation is a job killer and takes away things. So we're not going to talk about that today. We're going to talk about robotics. Let me start with this graph, which is the industrial robot market over the last 20 years. And you can see from the chart, it's the number of thousands of units. So if you look at 2014, we shipped about 225,000 robots globally. You can see there's a pretty pronounced change before and after the financial crisis. Robots were averaging about 75 to 100,000 units a year globally, and it jumped up to where it is. So largely being driven by China. So let me go back historically and kind of go back to the beginning. Do you want to play the tape?
Automation's newest contribution to man. This jack-of-all-trades robot is called UniMate, and it handles dull, difficult, or dangerous jobs with equal aplomb. His electronic memory helps him learn up to 200 separate movements. He has muscle, can pick up 75 pounds, and can stand extreme heat, cold, noxious odors, toxic gases, and radiation. He's accurate to 5/100ths of an inch. Not exactly sloppy, right? Perfect for heavy work or labor which may invite injury, UniMate is displacing 10 men at a time who are retrained for better jobs elsewhere in the factory. He costs $20,000 or rents for $7,000 a year. He never complains, asks for a promotion, or demands a pay raise. He doesn't break, bend, or burn, and should make some other UniMate a perfect husband. Or maybe wife?
Yes. Jim, I think I've got a date for Baxter, so you're lucky. Now, robots celebrated their 50th anniversary a little while ago. The picture is the first robot that went into factories, went into a GM factory, and really the beginning of robots was about dirty, dull, and dangerous. You know, I characterize this robots 1.1 or 1.0, And it's really, it kind of, if you go 25 years later and kind of the peak of that segment of robotics, it was really about superhuman capabilities, the ability to do things that people couldn't do. This is a welding line at a General Motors plant. And, you know, I think as any of us older people would know, baby boomers, that you didn't buy a car that was produced on a Monday or a Friday back in the 70s or early 80s because the welding wouldn't have been done right. But robots fixed that problem and really delivered a higher level of throughput. But they had their limitations. And I think this era, this Robots 1.0 era closed with the layoffs at General Motors in 1986, really because GM thought robots were the answer. Roger Smith went to Japan in the late 70s, saw that all the Japanese car companies who were building really good quality cars were using robots, and thought robots were the answer in General Motors, and bought a robot company to do it. And lo and behold, 6 years later, they realized it actually wasn't the answer because the quality wasn't there and the processes weren't right. So there was a retrenching in the industry, and it really gave rise to what I think is the era of productivity, the Robots 2.0 era. And these two videos are a good example of this. This was an era that went from the mid-1980s to right about the financial crisis. The robot on the left is working with machines, and it's really about productivity. So the robot on the left is making the machines more productive. There's lots of examples of this connected to CNC machines, molding machines, and other process tools where the robot's consistency really delivers a high level of productivity improvement of that machine. The one on the right is, I guess, the edge of the envelope in terms of robot performance. This is a kitting job where they're packaging cutlery, and you could see robots were just at a level of performance that weren't to be matched across the industry. The summary or the end of this era left us with this graph up here, which says that the biggest consumers in the world, the biggest beneficiaries over that era, were Korea, Japan, Germany, and the US. The lines in the middle are the number of robots per 10,000 employees, manufacturing employees per country. And so you can see that the highest density was in Korea, followed by Japan and Germany. And then the bubbles on the side is just the installed base. So again, Japan was number one, followed by the US, Germany, and then Korea. And you can see China way down at the bottom. That was all well and good, except for this mismatch. If you look at where robots are installed, and this is data from my company, you look at the donut chart. The vast majority of the applications are in machine loading and processing, robots 2.0 era kinds of applications. The interesting thing is where all our labor sits is in assembly and test, so which is the graph on the left. So there's a big mismatch today with where robots are solving problems and where the opportunities are to solve problems. And I estimate it's less than 10% of the potential tasks that are being automated today that are being solved by today's robots. So why aren't there more robots? Four basic things. One is that they're very custom. You know, if you look at a typical robot application, 60 to 70% of the total cost of the system is outside of the robot. So when you talk about a robot that's reusable, yeah, you can save 20, 30% of an overall system cost, but you throw away the rest. So you end up with custom, not reusable products. In our world, really short product life cycles and very aggressive ramps. Hard to calibrate and deliver and automate a cell that only is going to live for 6 months. And that's really been a lagger. And lastly, our direct labor in our factories in China and Mexico and in other low-cost labor markets is really good, really flexible, really capable, and not easily replaced by mechanization, certainly not the tasks. The other reason is that our factories, just like the world, is built around people. Processes are built around people. The kinds of things with the intelligence required, the dexterity, the physical size, the sensing capabilities are all built around people. And so putting in automated solutions that don't have that flexibility is a challenge. I like the picture on the right that really shows flexibility because this is the way a lot of our factories operate. we bring together things, solve short-run manufacturing problems, then we push them off to the side, we reconfigure it another way. And so that flexibility and reconfigurability really is important. So why does it matter that we solve this problem? Because we're about to embark on one of the greatest demographic shifts in the history of the world. This graph here is people over 60 years old, 100-year period that shows that from 1950 to 2050, the developed world had 12% was over 60, and by 2050, over a third of the people are going to be in that. The underdeveloped world has gone a similar trend, a little bit less. When you look at China, the world's manufacturing spot, the trend is even more pronounced. So the way that comes around to affecting not only labor but wages, I call it the 2027 Watershed. According to the Bureau of Labor Statistics, this is a graph that was put together a couple years ago. By 2027, if you extrapolate out, the U.S. will be less expensive than China for direct labor, which seems crazy, and especially with the devaluation of the yuan lately. But if you look back, it may not be so crazy. So this graph on the right is Mexico and China, and in 2003, Mexico is 198% premium. 188% premium over China. Today it's a 20% deficit. So for our factories today, we can get labor in Mexico for less money than we can get labor in China. It's another big trend that's really driving the need for flexible automation. We call it customization and personalization. This is what it looked like in 1920 for any of you who were there then. Henry Ford's famous statistic that you could have any color as long as it's black. Anyone know why it was black? Jim, you can't answer that, but anyone else know why it's black? Yes. Pardon me? Yes, but why just black? Why not red or pink or green? That's right, partially. Because black paint dried faster. So in a world where productivity was the driver, having a paint that dried a little bit faster meant that you could get cars through the assembly line faster. What it looked like in 2015, I like this. Any millennials? Anybody here with no, never mind. 38% of millennials have tattoos. 50%, nearly 50% of them have more than one. I do not have a tattoo, in case you were wondering, but if I did, that would be what I'd have. If the rest of that came with it. So why do millennials matter? This is actually an amazing statistic. Having lived in a world where everything that I've heard since I was born is that baby boomers are all that matter, and that everything related to products and services and strategies and everything else all built around baby boomers. Well, got bad news now. The millennials have taken that spot, and clearly the baby boomer number is just going to get smaller and smaller, so the influence of millennials is going to be dominant. So that's why it matters. This customization and personalization is going to be a big driver. Just look on the internet. You know, Nike's played around with personalized shoes. Millennials want glasses their way. The picture in the lower right-hand corner is a mobile phone from Google called Aura. It's a project that is about a configurable, customizable mobile phone that gets sold into the third world countries for less than $50. So, you know, we lived in a world where, since I was just got in the industry, we've talked about mass customization, and it's always been just a dream because customization meant huge costs and unrealistic value that could be derived. But the new generation's about getting it there at a reasonable cost point. So kind of what does the factory of the future look like? Hopefully not this. Anyone know where this is from? It's not China. Dallas, Texas. In 2013, this was the Flextronics factory building Motorola cellular phones in the US because Motorola is driving a strategy around personalization and customization. And the only way they could do it was with this, and of course, anyone know the punchline of the story, wasn't very successful. You can't build phones with 2,000 people standing on mezzanines in Dallas, Texas. Business was shut down, sold to Lenovo, and it's been moved to China. So that's not the factory of the future. But in parallel, I think a really interesting tipping point occurred in 2012. In 2011, Terry Goh, the CEO of Foxconn, made the statement that I'm going to put 1 million robots in over the next 3 years. Made that statement at a worker appreciation dinner. Don't quite understand the logic there, but it has not been as successful as Terry had projected. But you know, something else happened in the interim, which is in 2012, China put in more robots than any other country in the world. And in 2013, it put in 50% more than every other country in the world. And according to this thing on the left, by 2017, it will have the most robots installed in the world, making up for 50 years of history in Japan, the US, and in Germany, erasing that in 5 years. So the world is certainly changing, and it's driving a new paradigm in terms of how to think about manufacturing and how to think about the value of automation. So it brings us to the third era of robotics, which I call the era of interchangeability, the era of flexibility. Interestingly enough, it's not the robot industry that's driving it or that's making it possible. What's making it possible is a host of adjacent industry technologies, from computing to mobile computing to gaming to networking, that's delivering a new set of technologies that can now be built into new, smarter, more flexible, more agile robots, kind of like what Baxter is. And this enabling is opening up what I consider to be the next era of robotics. So what does one of these look like, or what are the capabilities that it have? I think there's kind of 6 core capabilities that I think really are the drivers for the next generation of robots that we've seen being put in our factories. You know, if I go left to right, clearly the way you interact with a robot, the HMI, will be much more intuitive, much more friendly. We'll really leverage a lot of the technologies that are coming out of the mobile computing area. Vision will be an afterthought. It's been two-dimensional for a lot of the previous generations, but with things like the gaming technology, three-dimensional vision has gotten cheap and much more powerful. The ability to work alongside people, no more big safety cages around robots and keeping them at arm's length. I love the one in the upper right-hand corner, force control. If you look at any one of our factories and you watch how our operators do a task, first thing they do is they watch it and they do it, and then you could blindfold them after that. And in a lot of cases, the ability to feel and touch and sense is actually a more important attribute than sight in a lot of assembly processes. So this idea of force-controlled robots, which Baxter is certainly an important attribute. Collaborative operation with other robots as well as people, and the ability to navigate autonomously through their environment are all the key characteristics. So let me give you some examples from our factories. You want to play the videos? So the one on the left is what I consider to be a Robots 2.0 application. It's an industrial robot, and because it's not safe, there's a big safety cage around it. You can play the one on the right as well. It's doing a simple in-circuit test handling application. The robot on the right, which, you want to go back one? Is it not connecting? Oh, there it goes. Is doing the same task. Nothing magical here, except that there's no safety cages. There's no infrastructure. There's a lot of money spent on the one on the left. It's a lot more inflexible. When we want to make a change, we gotta reconcile what the cage is. So you limit. So one of the value propositions of this new generation of robots is being able to be put into application with a much lower level of infrastructure. Same application, same technology, but probably about 30% less money and a lot more flexible. Then if you go to the next one, this is human-robot interaction. So in this case here, not only are there not safety cages, but people introduced into the environment. So people are able to work alongside the robots. In this case here, we've got two robots working side by side. We got people taking things from the robot's work envelope, inspecting it, may put it back, and it allows us to have this mode of collaboration now between people and robots, because we're not going to just place people with robots. You know, the factory of the future isn't the lights out factory, at least certainly not in the electronics industry. It's a factory that's a combination of people and automation working together to solve problems. Automation solving the problems that make sense for automation to solve, and people bringing their intellect and their knowledge to help solve those problems. Play this video. And then the third capability I'll highlight, this is a little AGV that we have that does line-side replenishment in our factories. Nothing too sophisticated. This is a technology that's just maturing today in terms of the autonomous navigation, but I would expect as we kind of think towards the future, this ability to have end-to-end traceability by having smaller lot sizes delivered to the line through autonomously navigated robots is going to be an important characteristic. And it's something that I think over the next several years will become a much more important part of our automation things. So that's robots. What does it mean for the supply chain? I think it means several things that are important. Again, I'm not a supply chain guy, so I can't take a lot of credit for being a visionary or an expert in terms of how to re-architect supply chains. But if I think about what robots' capabilities are, and this new, more intelligent, more collaborative, more flexible platform, it means that we can now deliver smaller lot sizes to the line. Just-in-time delivery. It gives us the ability through fully navigating robots to have end-to-end traceability of materials throughout the factory. When materials get to a station, a robot's smart enough to be able to qualify the material and ensure that what goes into the assembly is actually right and validated. Stations that reorder automatically, call in their order. Product changeovers that can match the speed of our customers. Speed, we heard earlier, is a common theme, and certainly Factory of the Future needs to support that. I love this full digital integration from supplier through supply chain to inventory, to the line, to the assembly, to the back dock, shipped to the customer, single digital thread through that whole environment. You know, today we got a break in the middle because there's a lot of manual processes that break that down, but when you can automate it and you can have full traceability through those automated processes, it's very exciting. Ability to capture real-time data, log it, process it, and analyze it. Again, automation is, robot is simply a physical embodiment of a computer, and the software do it. Reduce scrap, and most importantly, this interchangeability of robots and people. The ability to have people do tasks, have robots do tasks, have robots share and collaborate together, because again, Factory of the Future needs to be a combination of both people and automation. So how should we think about that as we think about our Factory of the Future? Well, if you look at how we're structured today at Jabil, we got plants around the world, but they're highly concentrated in certain parts of the world. We have a supply base that's all connected to it, largely concentrated very close to where our factories are. But if we think about this idea that automation can bring down the cost and normalize the costs of manufacturing to a point that we can make decisions about where's the best place to put a factory, and you take that and you connect that to the concept that we want to personalize and customize products, we want to put factories closer to where our customers are. And so you kind of think about how the map changes. The red squares now become facilities, factories that are located where our markets are. Of course, the supply chain follows. There still will be mega factories, but a much smaller percentage of them, and concentrated in geographies where there's also a big market, so it makes sense to stay there. And you can see there's a more aggregated view of the world. So let me give you a kind of a tangible example of this. This was just in the papers about 2 weeks ago. You know, I think it's I think it's a pretty good kind of vignette of this. The headline is Panasonic to close Beijing plant. Job losses at 1,000. Turns out 1,300 workers at the factory will be laid off. If you read the box in the bottom, it says the Osaka-based company is opening a new factory in the United States. It's in Las Vegas. It's connected to their customer Tesla to build batteries. Yeah, they're not the exact same batteries that they're building in Beijing, but quite a statement. Factory shuts down making batteries in China. New factory opens up in Las Vegas next to another manufacturer who's chosen to manufacture here because it's closer to their markets. So, you know, I think it's a small vignette to kind of how automation's going to make a play. If anyone's been to the Tesla factory, there's a lot of robots in that factory doing a lot of automated tasks to make it possible to build cars in Silicon Valley, which is kind of a crazy thought. Couple things to wrap up on robots. Again, I'm a robot guy, not a supply chain guy, so you get kind of a one-dimensional view of the world. I hope you appreciate it. This is from Boston Consulting Group, and it's about robots and productivity. And you know, if you read it, labor cost reduction and productivity gains due to robotics could have a big impact on countries' cost competitiveness. You look at the bottom, it says robotics offer an opportunity for both high-wage and low-wage countries to make competitive gains. The graph in the middle says that we're indexing the US as 1, and everything to the left is countries that are viewed to be putting in more robots than the US and will gain competitive advantage over the US over this period of time. And the countries to the right, in pink or red, whichever way you look at it, will put in less and will be less competitive. So interesting viewpoint. There's one last one that I will come back to. Yes, I could draw when I was 6 years old or 8 years old when they took that picture. Robots are one of the really powerful tools to engage kids into STEM, science, technology, engineering, math. I think Sharon mentioned this earlier. Really key. You know, I think the statistic is that China graduates more engineers every year than the US graduates students. So when you think about a world where science, technology, engineering, math are going to drive innovation, competitiveness, and ultimately standard of living, it really matters. And robots, through a variety of different organizations, really are a real driver in STEM and bring a lot of enthusiasm because they're fun. You know, and at 6, 7, 8, 10, 12, 15 years old, having an outlet where you can learn about science and engineering and math and see it physically happen. It's not a video game. It's actually something you can actually touch and see and play with. Really it inspires kids to be better at it and to choose careers in those areas. So any event, that's all I have for my presentation. I appreciate your time.
Well, okay, we're not going to let you leave so quickly, but let's give him a round of applause. I know you're dying to ask a nerdy guy who can't draw some questions about robotics. I mean, did you love that picture? You know,
can you believe my mom sent me to school like that?
Yeah,
I mean,
you know, it was a great
trying
image.
to do?
Yeah, yeah. So, what questions do you have for John about robotics? Yes, question in the back, Sharon.
So last week, I don't know if you've had the opportunity to work, I had an opportunity to hear from Maya Moderek, who's at USC, head of their robotics department. And one of the things she talked about is robotics as a solution for healthcare and the aging population, in the sense of, as the population ages, using technology and robots to actually sense and determine when individuals are having seizures, diabetics, etc. Do you work or have any insight into how robotics can help us with sort of these universal human issues around either agriculture or healthcare.
I actually heard a presentation about bed sores, you know, a robotic
Rotating 'em.
application for rotating on bed sore sensing. I think that's a great ad, Sharon. What do you think?
Yeah, I think first off, Sharon's kind of a ringer because her company's been using large volumes of robots for years to produce their chips in their factories. So,
And she doesn't look quite as nerdy as you did.
Yeah,
you
no,
know,
I'm sure.
yeah.
I'm sure her third grade picture doesn't quite look the same. She probably would have run if she saw that picture. Yeah, I mean, I think if you look at that graph I showed about China's aging population, I mean, Asia's got a huge, huge issue demographically with an aging population. You know, Japan, China, Korea, and there's been a lot of emphasis by the government, certainly in Korea and Japan, to develop robots to aid in elderly to aid the elderly to be part of the healthcare. You know, I think that the first you know, the reason that the factories matter is as soon as you leave you know, factory is a pretty definable space, and robots have really struggled to solve very much of the applications in a pretty defined world. So you leave that factory and you go into people's homes, you go into hospitals, you go into areas that are even less structured, less defined. It puts a lot more emphasis on the importance of the technology to be able to solve the variability and the environmental issues. So robots are making a big impact today in things like surgeries. Anyone who's heard of the Da Vinci robot from Intuitive Surgical has been a great success in terms of laparoscopic surgeries and so forth. Robots are going to make a big impact in healthcare. There's no question about it. I think with these more aware and intelligent robots, I think with better artificial intelligence to be able to navigate the environment. I mean, if you think about a robot, it's just the physical embodiment of a computer and the intelligence that comes from that computing. So as we get more sensor-aware technologies that make our robots smarter, they'll definitely make an impact. They're already making deliveries in hospitals. There are prototype robots in Japan about flipping people over for bed sores, as you mentioned, Laura, and they will certainly make an impact. We need to, because there aren't going to be people to take care of the elderly in the future.
So what do you think will happen faster? Last year we had a presenter who did a great job of convincing us that warehousing would be the natural next step for robotics. Will it happen faster in discrete manufacturing or warehousing? Any thoughts there?
I think they're both good targets. You know, I think that you know, I run Jabil's global automation activities, you know, and the thing we face over and over again is that we pay $9,000 a year for our labor. So every time we look at a project and someone's trying to do a financial ROI, if there aren't other intangible benefits, it's a pretty significant cost hurdle to get over to make complex automation solve those problems. Warehousing, which is largely a Western world phenomena, has very high wages. And so while I think that the challenges are equally challenging, the fact that there's a far larger pool of money to spend will make warehousing successful. I mean, look at Amazon. They bought a robot company called Kiva a couple years ago for $750 million. Everyone thought it was a crazy thing, number for a $100 million company. But they put in 15,000 of those robots into their warehouses.
Yeah, and Kiva was around for a long time and nobody was buying them. And then all of a sudden,
yeah,
Amazon,
they just got the momentum.
Yeah.
And of course, the interesting thing was that their play wasn't the robots. I mean, the robots were great. Their play was software. The ability to rapidly reconfigure your warehouse so that overnight, so that in the morning, all of the high runner goods were moved to the periphery of the warehouse to make it easier to make deliveries faster. So that was the real value proposition they had.
Other questions on robotics? That was your picture, right?
It was my picture.
Okay, all right. Trevor,
Yes.
was your picture quite
A lot
that
of
bad
cosmetic
when you were
surgery
in
got
sixth
me to
grade?
here.
I mean, you
Yes.
look like you could have had a nerdy picture. I don't know about it. You know?
I think next year you ought to make everyone put their pictures up.
Wouldn't that be
Yeah.
great? The
Yes.
sixth grade pictures. Yeah. What do you think,
Exactly. That was
Trevor?
third grade, by the
think
way.
I didn't have the glasses at that
Yes.
stage,
Oh,
but I think
okay.
my picture would have been just as nerdy. And
Yeah.
in fact, I even had a tie with a few stripes on it.
You know, I think that we might have had a few nerdy people. I could have showed you my picture, which was pretty nerdy also, with the horn rim glasses. But go ahead.
But a quick comment on STEM, because I love it. My middle one went through the whole robotics program and all of this sort of
Lego
stuff.
League and First Robotics. And
Yes, and then he went on to do economics, and now he's working for not-for-profit. So, you know, just thinking about all of those scales and going through that. But the real question is, you made some comment about robots aren't going to replace people because people have more flexibility and all of this type of stuff. But then we've been talking all about the fact that people are going to be replaced by robots. So trying to reconcile that on one level, because how I see it manifested in supply chain is that we still believe that you can push a button and some computer's going to tell you what to do in the supply chain, and you can just disengage the human brain.
yeah.
I don't believe that at all. I'm just wondering how you see that in robotics as well.
Yeah, I think it's the same. I think it's the exact same analogy. I mean, there's no question that there's a lot of tasks that people do that will get automated by some kind of mechanization. If it's a robot, it's a robot. It may not be. So there's no question that that happens. I guess my view is that I don't think it will be in my lifetime that we'll see these fully automated factories unless you can really define the parameters such that you've created an environment where the robots can operate in. You can't just put robots into people environments and expect them to go replace people. So I think as I think about factories of the future, actually I think as I think about factories of the future, it will be a combination of both people and robots. And yeah, over time there'll be more mechanization and less people, but I don't see people leaving. Again, there's a great article in Supply Chain World magazine, I think it's October of last year, about their view of the factory of the future. I love it. It talks about agility and responsiveness as number one requirement. Number two, the digital factory, data-driven, information-driven. And the third, knowledge workers and the importance of knowledge workers. Three pinnacles for the factory of the future, and people are at the center of it.
So 2025, what does the robot look like?
Ask Jim. He probably knows better than me.
Jim, what's the robot look like in 2025? Bring him a microphone. Yeah?
Just like Baxter, right?
Jim works for Rethink Robotics, and he brought Baxter last night, so
Yes.
it was lots
I hope
of
you all
fun.
got a picture.
Thank you, Jim. So
I
what's
guess
it
one
look
of the
like?
things, John, that you said that really resonated with me is I think factory robots really are the physical embodiment of a computer. And so you think about where computers are going to go when you start to take the intelligence of artificial intelligence and machine learning and deep learning, and you hear about a lot of these kinds of technologies, and fuse that with some of the advanced manufacturing capability. You've got robots now that are going to be able to learn from each other. They're going to be able to figure out things like, if I have no idea what this is, and I'm a robot, I'm going to be able to take a picture of it, shoot it up to the cloud. It's going to send me back information, and as a robot, help me understand what do I actually do with this thing that I haven't had before. So I think we're going to find these robots are becoming much smarter. They're becoming bigger enablers of people. I think the other point that you said that really resonated with me was the factory of the future, I think, is really built on people and robots working together. I had someone tell me fairly recently that, in fact, it's public knowledge, it's a guy at General Electric. What he said was, for a long time when you hired an engineer, the engineer always got a calculator. I mean, they got a set of tools that they used. In the future, the factory worker is going to get a tool too, and that tool is going to look like a robot. So they're going to have a partner with them where the person, the factory worker, and the robot are working together, and it really is going to be a 1 + 1 = 3. I think we'll see these robots. I think manufacturing is where they're going to show up first, but to the question that you'd asked a little bit earlier, the same technologies of you show them what to do, they're very safe to be around, they're really cheap, they're going to end up in homes, they're going to end up serving us coffee, they're going to end up supporting elder care. I think it was, I can't remember, one of the CEOs of the major high-tech companies that said, at some point in the future, every decision that we make is going to get supported by technology, and some of that technology is going to take the form of a robotic assistant. So.
I heard a presentation at a medical convention the other day that said that the supply chain of the future for healthcare will have 3D printing of medical devices, a robot to put it in, and Internet of Things to sense your health, right? And so I think this whole combination of technology gives us great flexibility to redesign industries.
Yeah, I think everyone here ought to be thinking about 3D printing, in terms of the supply chain of the future. It's still in its infancy. It's been overhyped. It's kind of coming back down to a little sense of reality, but there's a lot of very exciting technology coming, and the idea to be able to this whole idea of, to me, the whole idea of reshoring is going to come when you can personalize. You need business models, I think, just like we had earlier. Business models are going to drive reshoring. It's not going to be patriotism. It's not going to be because we got cheap robots. It's going to be new business models. And I think one of the big ones is this idea to be able to personalize and customize products for the end markets through 3D printing and through a higher degree of automation that allows you to do it cost effectively. Yeah, it's going to be very powerful.
Well, thank you so much.
Thank you, Laura.
I loved your
Appreciate it.
picture.
Oh, thank you.